problem 2-1 and 2-2. Yeah, first say, I'm gonna leave an email in the description. So if you have any questions that you would like to see up on here, or you would like to just see the solution of it, or my solution of it, I'm more than happy to either post a video or send you the solution. Like I said, the email will be in the description. Please, if this video has helped you out, like or subscribe. Helps me out. So here we go. Let's start with 2-1, and these are both kind of simple. Adding vectors. So basically, what it's stating is that you have, so in 2-1, it's giving you the actual magnitude of this force being 150 newtons, and it's giving you the theta being 60 degrees. And you have the 700 here. I'm going to note being like vector A, and that's vector F. And then you have to add those together to get vector R, the resultant vector. There's two ways of adding vectors. There's the head to tail method. Basically, you have that there, and then you take that's a 450. That looks like 456. Let me fix that real quick. There we go. Right. And then you would have this, which would probably be somewhere there, and then your resultant would be from the tail of this vector to the head of this vector to give you that. But doing this way requires like a lot of geometry, a little too much for my taste. So what I like to do is take the vectors and split them up into the I hat and j hat, meaning this would be the the x value of it. This would be the y value. Basically what that means is we have this vector, and this is, so we have 60 degrees, that's 450 newtons. And basically, so your I hat would be from here to here, and your j hat would be from here to here. So this being along the y, and this being along the x. So simply, if we're doing it for this force, 60 degrees, all you can do is do 450 times the cosine of 60 degrees. That gives you the I hat. And then 450 times the sine of 60 degrees. That gives you the j hat. Oops. There you go. So, and that's it. And that would just come out to be 225 I hat plus 389.711 j hat. So that's that force into I hat and j hat respective. So now, go ahead and get rid of all this up here. Save me some space. So now, what we have to do, which we have to do the same thing, but for, oops, okay, but for that 700 newtons, 15 degrees down this way. So an important thing to look out for is to see that So like this is going down like that. So that means, and we know that when we're looking at our lane, this way is positive, this way is positive. So we know my I here is negative, and we know my j hat is also negative. And we know that just by looking at that 700. So basically what that means is that when we're doing this, we have to put a negative front of also we're splitting it out. Sine degrees. Yeah. And that's because if you do the cosine of 15, you'll get like a positive number in there with the sine of 15. But we know by looking here that it's negative in both directions. So then that will give you a of negative 676.148. Now I have minus 181.173. And now, to get R, all we have to do is A plus F. Now we basically do just take a look at the I hat and F, and I hat for A. We just add those together, and that would give us F I hat for R, which would give us a negative 451.148 I hat. And same thing, but in the J hat, we just look at each part and we just add those together. And that would give us plus 208.538 J hat. And now, basically what that means, if we're like looking at it, if we're looking at that, that means R, like there's kind of like where I draw it, but a little less. It's mostly this way, kind of like that. And then we have X here being 451.148. And we have the Y here being 208.538. And basically, so now we just have a right triangle, and now we're just solving for the magnitude of that, and we're solving for the angle. So, good way to solve for the angle, especially so like I'm writing this out. This is J hat, this is I hat. Simple kind of solutions. The magnitude is just equal to the square root I hat squared plus J hat squared, and then the angle. Did that awfully. No, it's theta. It's going to equal to tan inverse J hat or hat. So this way, these are basic equations. You could use these for any vector that's given to you like this. Just give. So let's see for the theta J hat or I hat, but it's really the absolute value of this, because when you do this, it's going to give you this angle here. So if you like left this negative, it would just basically make that a negative angle. So you want to keep the absolute values of these. So when we do this for R, the calculations, we get 497.011 newtons by magnitude, which makes sense because it's mostly dominated by this, and we also get it. So let's look from the angle that we found. We get that angle. It's 24.808. And that's, of course, going in this way. But the question asks it for a question asks us to measure that angle from the x-axis. It's this, so you just do 180 minus that to get 155.190. So, and that's it for problem 2-1. For 2-2, right? So, carries all this off of it. Getting slow. So now for 2-2. So it's asking the magnitude of the resultant forces to be 500 newtons straight along the positive y-axis to determine the magnitude of force F in its direction theta. Basically, that means is that we're going to have our R just straight up at 500 newtons. And as you guys know, you already know this one over here is equivalent of A. And now we just don't know our force here in the angle it's set at. So it's actually not as hard as you remembered. To get R, we did A plus F equals R. So in order to get F in that, we just do R minus A with F. So, and we know what A is, because we just figured that out, and we know that's negative 676.148. That's 181.173. Yeah. No R. No R because it's given. R is just simply 0I plus 500. Yeah, you don't have to include this. I'm just including it for the sake of continuing of the I and J format. But you could write it just as R 500 J hat. So, but so now, in order to find F, all we do, we take this and subtract it to this, take this and subtract it into this. So basically, what you get that is equal to 676.148 I hat, and then plus 681.173 J hat. So now, you do the same thing as before. Magnitude to the square root A hat squared J hat squared by theta to make it to my tan inverse of the value J hat match the value of A hat. So just gonna pull my calculator real quick. Okay. Right. So basically you can kind of see that this is almost at a 45-degree angle, by the way. So you do 6.148 plus 681.173 squared. Square root that. So you get a magnitude of 959.777 newtons. Oops, didn't mean to do that. Newtons, and then you get an angle of times tan of 6 1.173 divided by 676.148. So, like I said, like it's really close to 45, so it's 45.212 degrees. And this angle is fine because it's being measured from here. Um, you can kind of tell sometimes when, especially when it's close to 45, because the I hat and the J hat would be the same. Thank you guys for watching. Like I said, in the description below, there's going to be an email. You can contact me that way. Problems, see if you want to see it up on here or see the solution, and that'd be great.